Hello, and welcome to week 4 of Basic Mathematics. This week we will look at decimals. Now, there's a name for every position to the right of the decimal point, just like there are names for positions to the left of the decimal point, like the tens, the hundreds, the thousands, and so on. Well, we also give names to things to the left of the decimal point, to the right of the decimal point. That 1 that you see here, that's in the tens position. It's pronounced tenths position. The 2 is in the hundredths position. The 3 is in the thousandths position. The 4 is in the 10,000th positions, and the 5 is in the 100,000th positions. Notice the TH added to all these things that designate to the right of the decimal point. So how do you say these things? Well, in real life, perfectly honest, I would call that 4.1 and I'd call that 0.12, but there is an official name for these things. The first one is 4 1/10. The second one is 12 hundredths. The third one is pronounced 6 123 thousandths. And the last one is 72 589 thousandths. That's just how that's pronounced. I want you all to know how to convert a fraction to a decimal. And how do you do it? Yeah, you do the division. Any calculator would do this for you, of course, but you're not allowed a calculator on the exam, so you'll probably want to practice this. So 1/2, 1 divided by 2, you should come out to 0.5. 3/8, do the arithmetic there, you're going to get 3 decimal places, 0.375 or 375 thousandths. I had to think on that one. 2 1/5. The whole number part you don't have to worry about. That'll be to the left of the decimal point. So just convert the 1/5 and you get 2 2/10. 1/3's a weird one. Why? Because it's a decimal representation. Goes on literally forever. 3, 3, 3, 3, 3, 3, 3, 3. Of course, you don't write it that way. You'll see it with a bar written over the part of a decimal that repeats. I could have written this as just 0.3 with a bar over it. Sometimes you'll see, the first 2 numbers or something like that, just enough to show what the pattern is. So now let's try dividing by sevens. Okay, 1 divided by 7 will give you a very, very long number. It looks like just jumbled numbers, but you'll notice there is a pattern. 142857, then it repeats 142857 and it repeats again. So you would write that excuse me, with a bar over 142857. Now let's divide 2 by 7. Okay, again, you're going to get a repeating decimal. This time it starts at the 2, 285714. It's the same pattern though. If you look at the 2 here, 285714, and then it repeats, it's basically the same sequence, but it has a different starting point. The same thing with 3 divided by 7. This time we'll start at the next highest number, which would be 4, I believe. Okay. 428571, which you'll find right there, 428571. And then it just repeats and repeats and repeats and repeats. Same thing with 4, but that one will start at the 5. 5 divided by 7, and that one will start at the 7. And 6 divided by 7, it starts at the 8. So basically, if you know this one sequence, you would know the repeaters for all of the ones in the divisible by 7. This makes an interesting parlor trick. I've seen people at parties, the parties I go to anyway, where someone will say, oh, give me a 2-digit number, I'll divide by 7, and I'll calculate it to 30 decimal points. Oh, really? How does he do that? What's going on in his head? Well, not very much. All he has to do is take 31 divided by 7, which is 4, with a remainder of 3. The remaining pattern will be this one, the one that starts with 4, 428571, 428571. So he'll give a big roundup, and he says, oh, I believe the answer is 4.4285714, 4285571, and just keep repeating the pattern as if he's calculating this all in his head, but of course he isn't. It kind of looks impressive. You should try it with your friends, do it at parties, and see if they're impressed. Okay? Okay, let's convert decimals to fractions. That's fairly easy. All you have to do is take the decimal part and put it over the proper power of 10. That 5 we're going to put over a 10. The 27 we'll put over 100. The 125 we'll put over 1,000, and so on. So let's take the 0.5, and we have that as 5/10. That can be reduced to 1/2. Take the 27. You get 27 over 100. Now, can that be reduced? You might remember from week 2, we talked about what numbers divide others. 100 can only be divided by the prime factors of 2 and 5. So if you can't get a 2 or a 5 into the numerator, don't worry about it. You can't reduce it. So that's as far as that one can go. 125 over 1,000, well, that has 3 5s in it. You can divide top and bottom by 5, top and bottom by 5 again, top and bottom by 5 again. You end up with 1/8. 296 has a whole bunch of 2's in it. In fact, it has the number 8 in it. Divide the top and bottom by 2, you get that. Divide the top and bottom by 2, you get that. And divide the top and bottom again. And finally, it's reduced to its final form of 37 and 1/25. Well, 37 over 125. What's bigger or smaller than pi? This helps you just go over how you compare some of these numbers. Here's a decimal equivalent of pi out to several decimal places, 3.14159265535. So let's compare. 4, of course, is bigger than that because this number is less than 4. It's 3.14. So that one's bigger. 3.2, well, you're going to compare the 2 to the 1. This one is also bigger. 3.14. You might say those are equal, but they're not, of course. Pad this one with zeros. So it's 3.140. You're comparing the 0 to the 1. This guy is smaller. 3.1416. Well, this is 3.14159. So you're comparing the 5 to the 6. This number is bigger. 3.1409999. 3.141. Compare the 1 to the 0. This guy is smaller. 3.1415916. 3.1415926. This guy is smaller. Okay. And that's how you would do that. That's this week's lesson in a nutshell.